There are three types of covalent bonds, either single, double, or triple bonds. And when we start to build these structural formulas for molecules, we need to know the number of covalent bonds that an atom is going to make. So a quick recap on remembering the rules for how you determine the number of covalent bonds. It's how many electrons are needed to fill their valence orbital, that outermost orbital. Okay, so take a quick minute here to remind yourself of how many electrons each of these atoms need by drawing orbital diagrams and seeing how many fill their valence shell. Okay, so hydrogen has only one valence electron. It needs just one to have a stable outer orbital filled with 2. Oxygen, atomic number 8, has 6 valence electrons and therefore only needs 2 more electrons to fill its outer shell. Nitrogen, atomic number 7, has 5 valence electrons, therefore it needs 3 to reach that stable octet of 8. And finally, carbon has an atomic number of 6, that's 4 valence electrons. It will need another 4 electrons for that stable octet. Okay, so let's take a look at single covalent bonds. These are the simplest of covalent bonds, just one pair of shared electrons between a couple of atoms. And they are represented by just a single dash. So for example, dihydrogen gas, H2, would just be written with a single dash between the two hydrogen atoms. Okay, so take a second to pause the video and figure out how to draw C2H6 using single bonds. Okay, so you're drawing ethane. Now, one of the rules to start with for these organic molecules is to always connect the carbons first. There you have a carbon backbone. So we see there's 2 atoms of carbon, so go ahead and connect those with a single bond. And then the next rule is to always think symmetrical. Okay, so we have 6 hydrogens. So put 1 on each side, there's 2 of them. There's another 2 for a total of 4, and then there's the last 2 for a total of 6. Now when you're done with all your atoms, you got to do a little checklist here. See that you've used each of the atoms in the molecule, C2H6, that's done, and that each of the atoms has the correct number of bonds around it. So again, from that first part of the video, you know carbon needs 4 bonds. You see each of these carbons are making 4 bonds, and each of the hydrogens need to make 1 bond, and that's the case. So this is the structure of ethane. Okay, so now again, pause the video for a moment and take a turn at using single bonds to make methylamine, CH3NH2. Okay, so once again, you want to start by bonding together the atoms that will make the backbone. Now in this case, we only have 1 carbon, but we also have a nitrogen, so you can feel safe in bonding those 2 together with a single atom. Always save the hydrogens for last. And then start filling in. Now what we see is that nitrogen likes to make 3 bonds, therefore it can only make another 2 bonds and 1 additional to carbon. So fill in those 2 hydrogens, and then nitrogen's done at this point. It's made its full 3 bonds. We have 3 hydrogens left, and of course those are going to go on the only remaining atom that they can go on, carbon. Check that you've used all your atoms at this point. We have, and that each of these atoms have the correct number of bonds around them. So carbon is making 4 bonds, N is making 3 bonds, and each of the hydrogens are making 1 bond. Okay, so on to double covalent bonds. This is when 2 pairs of electrons are shared between 2 atoms, and you'll represent this with a double dash. In the case of oxygen gas, O2, you would just put 2 covalent bonds between those 2 oxygen atoms. Okay, so once again, pause the video and see if you can come up with the structural formula for ethylene, C2H4, using a double bond. Okay, so again, you want to start by bonding those 2 carbon atoms together, the carbon backbone of organic molecules, and then think symmetrically with your approach to filling in the hydrogens, so 2 on each of the carbons. And now at this point, we have used all of the atoms, C2H4. However, carbon does not have the correct number of bonds around it. You see both of those carbons only have 3 bonds around them. They each want to make 4 bonds. They need 4 electrons, and therefore to solve this situation, you would put your double bond right there in the middle. Those carbon atoms are sharing 2 pairs of electrons with each other. Okay, so now take another turn here at coming up with the structural formula for formaldehyde using a double bond. Okay, so once again, we only have one carbon atom. You're going to bond that to the oxygen. And then in this case, you could try a few different things with the hydrogens, but none of them will work unless you put those hydrogens onto the carbon. Okay, now at this point, we've used all our atoms. Carbon has made only three bonds total, however, and it needs 4. Oxygen's made only 1 bond, and it needs to make 2 bonds. It needs 2 valence electrons. So we solve that by putting in that double bond between the carbon and the oxygen. Now all of the atoms have the correct number of bonds around them. And finally, the triple bond. This is when, of course, 3 pairs of electrons are shared between 2 atoms. This is a very strong bond represented by a triple dash, as in the case of dinitrogen gas, N2, with those triple bonds between the 2 atoms. Okay, so now take your turn at figuring out acetylene, C2H2, using the rules we've followed so far. Okay, and once again, you should be bonding your 2 carbons together first, and then thinking symmetrically with regards to the hydrogens. At this point, we've used all the atoms in the molecule, C2H2. However, each of the carbons has only made 2 bonds, and each of them need 4. So they each need 2 more bonds attached to them. They can't do it with the hydrogens because hydrogens only make 1 bond, and therefore you're going to fill in those 2 additional needed bonds there between the carbons. There's a triple bond between those 2 carbons in acetylene.